Hello, welcome to our lab 4, which is on ADS, another tutorial software on the software called ADS, which stands for Advanced Design Systems, developed by a company called Agilent. So we will have two labs, two sessions on this software, and is going to be held today, and another one is in the next session. Today is a very basic tutorial. The tutorial is very self-explanatory and very easy to follow if you just follow step by step. And the next one, we will go in details with transmission lines, including Smith chart analysis, S parameters, and we will also cover we will also cover the tuning or some stop tuners to match the impedance. So today's lab is really important for the next lab, because we are also having today a bit of transmission line and also this parameter and Smith chart. So let's move on. First we have to open the ADS, and I hope you have that already, given that you have followed the instructions very carefully. You might have different versions from me, from what I have, but that's fine. It doesn't vary a lot. It doesn't differ a lot. More or less they're same, all the interfaces and options. So okay, let's open that ADS. You can follow with me if you like, if you have that in your computer as well. So well, this is sort of a licensing thing. I'm not sure which one is working. Let's try. Okay, so first thing that you have to open the workspace. This is the main window of ADS. To do that, you see that at the very top right corner, W folder, it looks like folder W, which is the button to open the workspace. So click on that, and just you name it. I'm just keeping it as it is. So what happened? Anyway, just click on that, then new schematic window. Again, I'm not changing the name. In fact, you can change. You can select the destination as you like. So okay, so this is our workspace, where you will have or draw in a circuit. I think I forgot to mention that the ADS, this is a 2D simulation software, unlike the CST and HFSS. And so if you remember the software called Circuit Lab or PSpice, pretty much close to that. However, ADS got more functions, such as especially if you want to design an RF system. Let's talk about that whole system. If you want an overall representation of any RF system, sort of block by block things, or circuit, or in a schematic format, well, ADS could be an option, a very good option, and also it's very user friendly, and it works pretty fast. So this is kind of like 2D circuit simulation software, and we can do. We use this software a lot for RF designing as well, but definitely in 2D format. I mean, in 2D simulation format. Okay, so let's come back. Let's stick to the tutorial. Now we have done that already. It's all about like saving the things, so you don't have to do that right now. If you want to save it, you can save that later. Okay, let's there's some introduction about the window that we have right now. Well, I said that a little bit of difference. I'm having 2020 version. You might have an upgraded version, so it doesn't matter. This is these are all same, pretty much same. Well, so this is the, as I said, that this is the workspace, and you see that to your left hand side, this is our component palettes, where you can, there's a drop down box, you can do a lot of things here. For example, if you want to look into the basic components, you see, you know these components pretty much, resistor, capacitor, diode, and transistor, and other things. And then this the tools and options, you know. All right, so it just does it. Okay. All right. So first thing, as we were, as I said at the beginning, that we will be looking at the transmission line. We will construct a transmission line. So let's go back to the workspace, and you will find that if you select the transmission lines ideal, you don't have to worry about the other things. We're just interested in here actually. So pretty easy. As I said, the interface is pretty easy. You just left click on that thing, you come back here, and if you just click again, left click on the in the workspace, okay, yeah, if you click more, yeah, it's okay. And if you want to get rid of these options, just press escape. Okay, since we need only one component like this, so again, deleting is pretty easy. Just click on that thing and press delete. And if you want to change the property of this transmission line, just double click, and you can say, for example, you heard about this impedance, which is called characteristic impedance, or it could be anything, any impedance. Okay, so let's follow the tutorial. In this case, what they're telling us to set the impedance as 86.6 ohms. So let's do that. So, okay. Okay, and frequency is probably 2.5. Okay, we can ignore this, but this is you see, this is in terms of degrees. This is called electrical length of any transmission line. I'm assuming you have heard from your theoretical classes. So electrical length, which means the length in terms of frequency, or in terms of, in other way, you know, in terms of wavelength. So this is the expression of electrical length, and this is really important whenever we are talking about the transmission lines. And also, well, we have physical length. So when you express the physical length in terms, I mean, sorry, let me paraphrase this way. I mean, the physical, the relationship between the physical length and the wavelength. So, and that is how you can formulate these things if you want that length in terms of any physical length unit. However, you can get that in terms of degree as well, which is the case for the areas. So so you can do a little bit of exercise here as well if you like. In fact, this is the part of your lab report. So all you have to do, you have to just convert this 90 degrees length in terms of this electrical length. So you can just use these formulas. All right. If you are not sure about this, just shoot me an email and I can clarify that for you, or I can help you with the solution. Okay. So yes, we are just keeping as it is, as I was saying, which is 90 degrees, and you have to calculate the respective electrical length for that 90 degrees. Okay. All right. So you're done with that. Once you are done, just press apply and press OK. That's it. So you're done with the transmission line component. Basically, you don't have to go anywhere else since we are just talking about the transmission line. It's very easy, although there are so many options here. Drop down box. So what else? Then we are going to add, if you want to add something, let's say you want to add a ground. There is ground. You see, whenever you see some red dots at the end of any, or at the terminal points of any component, that means this connection is not complete. So you have to complete the connection. Okay, so you can complete it either way, but well, for example, if you just put a ground here and if you just pull that wire from here, there we go. So it's blue means it's okay. But anyway, we are not we are constructing a transmission line, so we are not doing this. Just double click on this thing. Sorry, just press escape and okay, we will need this anyway because we are putting the terminals. So this is our basically the transmission line, the wires. However, you know that there are two sides of any transmission line or any transmission system. One is source and the one is load. And normally we just put some impedance or registers over there. So you put two terminals here. One is at the left side, which is this. For example, if this is the generator side or source side, and the other side is the load side, we have to put another terminals. So let's forget this here right now. Let's put the terminals first. In that case, again, click on that drop down box. Go to simulation, S parameters, and here you see it's small, it's tiny things. Here, see, that's the terminal. Let's put one here and put one here. You will need two since we are having two sides. Okay. Okay, these connections are not complete as I mentioned before, so you have to connect them with the wires. Stay locked. You have to connect a ground here. There you go. This is sort of a complete transmission line, and we need anyway. I mean, well, I mean, as I said, that if you just double click on any component, you can change the property, you can change the parameters. In this case, probably we will just keep as it is. You can change the number or serial, you can change the impedance, and change anything, so whatever you like. We are not looking into these things right now. So and for example, probably based on your tutorial, I think we have to put 150 at the terminal 2. So let's put 150 at terminal 2 and press apply. This is changing straight away there. And also yeah, we can put any value of I need to show thing, I think, because sometimes we just miss the syntax. There should be some specific pattern or way that you put the value here. So for example, if you want to put 50 is fine, but that's fine. But if you want to put some complex or impedance values, in that case, let's say I want to put like 50 plus or minus J25. In that case, then J asterisk and 25. I hope this is right. Yeah. Right. So you can put this way. Just don't forget, otherwise this will not run, or maybe this will not take the value. So let's put it here. But you can just click on that thing. You can change that here as well. Anyway, so now we have to there are ports whenever we talk about the microwave system or transmission lines, and there could be multiple ports to calculate the S parameter. For example, if you heard about that wave, the wave gets generated from here, it goes through this and gets reflected back or gets transmitted. So basically these things happening between the ports. Okay, and I'm not sure whether if you heard about that S parameter or transmission coefficient or reflection coefficient in terms of the amplitude. So this is really important parameters whenever we are designing any RF systems or any RF components or antennas. In that case, so we have to put ports at the both ends. Let's say port one. Let's say put one this side and put two that side to measure the S parameter and other things. Okay, so for these, you don't have to pick anything from here. Go to that toolbar and go there, just under this simulate. That's the pin. So you can put it here, but it's gonna be a little bit of chaotic here. So let's put it somewhere there. Let's put it somewhere there. And we are done putting. So let's press escape. You have to rotate. So you can rotate either using this option, or you can press Ctrl R. It's Ctrl R, all right? Or you can use these things. So we are just keeping them a little bit away from the circuit, so that it looks good and also it doesn't look messy. So let's put some wire here. So we don't have to change the number of ports. Okay, so this is a complete transmission line. All right. So let's go back to the tutorial. Make sure that's the transmission line looks like this exactly. Okay. Yeah. Now we are measuring the S parameter here. That means we have to go to this option here. Just click on that thing, just like a component. Exactly similar things. Okay, you are not putting another S parameter here. Just press escape. You're done. Now, definitely you have to change some setup of this parameter. For example, what would be your static frequency and what would be your stop frequency and what would be your step size, or at how many intervals the plot would be drawn. Okay. So in that case, you have to fix this thing. We can put any value, whatever you like, but let's follow the tutorial for now. Here you see it's 1, 5, and 200. So that's 1, that's 5. It's not 200 gigahertz, it's megahertz, so you have to convert this to megahertz. And let's put that number of points, 21. This is sort of like how good the plot would be looking. I mean, the higher numbers means, I mean, the plot is more smoother. Okay, so lower numbers, you may see some quantization things. Okay, so we are interested is the normal thing, the 21. So we don't want to rather change it. We don't want to change it. So yep, I think done. Make sure when you press apply, okay, now you see that nothing is showing up here, step size. So let's do one thing. Just press gigahertz. 0.2 is the same as 200 megahertz. Yeah. So maybe it was working, but I'm not so sure. It might be a glitch or something. So let's just skip that. Okay, so that is what that is the instruction. Start frequency 1 gigahertz, stop frequency 5, and number of points 21. So I think we are done with everything. We have drawn this circuit, or drawn this schematic presentation of the transmission line. We've done the S parameter. Let's simulate. Okay, multiple windows will be coming off once you click on that simulate. That's fine. Let's see. So let's not look at this first. Let's look at this first. This is a sort of like, you know, status box or message box where you can see any warnings or errors or the status of the simulation. Okay, it's pretty cool, right? It's very quick, that you don't have to wait and wait and wait, that you had to wait in the case of CST and HFSS. So remember, as I said, those are three-dimensional simulation software that performs the whole calculation, a lot of calculation. So definitely that will take a while. However, let's come back to this screen. This is your results window. Okay, this is the window to bring out all the results that you like, and these are the things. Again, same thing. You have to just click on that thing, and just it will be brought up here. So this is S parameter, rectangular plot. This is Smith chart, and so on. Okay. So this is a kind of like stacked rectangular plot. So let's click on that first. There we go. Something is coming up. Plot traces and attributes. You have your plot options. You have access setup, plot title. You can put the plot, because we are interested in the S parameter right now. If you want, so you are not done yet. You have to click or choose the S11, and then you have to add these things to this list. Remember, this is a typical unit for S parameter. So decibel always. So we are interested in decibel. We are just not changing anything here. There you go. So still you can do, let's say, if you want to put. Okay, we'll not put that because it already says there. So yeah, that's fine. Just so thing is that, like, we have designed the thing that will be operating at 2.5 gigahertz. We have already done that. There you go. And so many windows anyway. So yeah, so this is the S parameter, S11 actually, to be specific. And if you want more, let's say I want to delete this. I want more. Okay, let's say I want to put, because you see there are two ports here. One and port 2. So you will have like 4 S parameters: S11, S12, S21, and S22. Both transmission coefficients and reflection coefficients. Okay. for the both ports, or between the both ports. So let's go back to that result window. We on all of it. Yep. Okay, well, it looks like you are having two only, but remember we are having the similar parameters and we didn't change any value here at port 1 and port 2. So if you see that from the port 1, someone is looking at from the port 2, it's going to be the same. So basically you are having all of it. We're having four. They are just kind of like overimposed there, so you don't see them separately. But if you want to see them separately, there is another option here. Let's keep it here. The stack thing. All right. Want all of it here to see how it looks. Let's add. Looks nice, isn't it? You see, this S11 and S22, both of them are same. That's why you cannot distinguish. Same goes for S12 and S21. Okay, so this is a very nice way to represent all of the S parameters using this stacked rectangular plot. Okay, so how far we are we have done here. Okay, yeah, there are some options to play with the plots. Not pretty much of the things that you have to look very seriously. You just, if you want to change the type of the plot, let's say you want to change it, change the axis, you want to change the plot title, you want to make some plot title. Let's put something like test. So you see it's coming up, and if you want to discard one of these, for example, if you want to discard this from this plot, let's discard both of it. It's going away, and also just bring them back again. You want to change the color, you want to change the thickness. Well, it's just something that it's a great thing to play around. Okay, all right, so you can change the scale as well. You can change the appearance. All right, so let's have a look at these questions. You might have to answer those questions as well. So 1.4 gigahertz. We have used 1 to, sorry, my mistake, is 1 to 4 gigahertz, but we have played with 1 to 5 gigahertz. There are some more. It's pretty much similar, exactly the same thing that we have done right now. It's very easy to answer. Again, if you are stuck, just let me know. Okay, now let's have a look at a different plot. Looks like, see, let's clear the clutter first. So this is Smith chart. Okay, so if you want to have all of it, here we go. Okay, so this is a Smith chart. I think you've heard about this already, or maybe you've done already. Okay, you don't need a pencil or paper or a scale or anything, or ruler. Just ADS does that for you. It's a pretty easy, space interesting and nice and cool thing. So you see, it shows the range, and also these are the circle for S11, circle for S22, gate away. One is away from the port, one is, this is the generator side, this is the load side, so they are just kind of like opposite to each other. Okay, this is the transmission coefficient. So uh, what the thing that you have to do here is put a marker on it. Use of marker, it's very simple thing. Let's say you want to read a data along the circle of the S11. Well, it's already showing up here, but if you want to show that to somebody else or to us, just click on that marker. There you go. You see, you can see everything. It's at frequency is 4.2 gigahertz. This is 0.45 decibel. 25 impedance shows the impedance as well. If you want to put more marker, put more. I'm putting more because probably there is a question or exercise for you. It says just have some comments as you put several markers along the trace, how you are seeing, I mean, what sort of changes happening. Okay, maybe you can just put some comments. Okay, see if you can interpret the results. All right, so definitely that will be changed because as you put as you pick different points along the surface, that means you are changing everything. You are changing the frequency, you are changing the impedance, you are changing the and so this parameter. So definitely if you change the value of frequency, you S parameter along, if you remember the S parameter curve, let's say for example, okay, if you just move along the frequency here, let's see that the similar value of S parameter here. However, you can see the impedance value, which is why this is really handy for you. Okay, this feature and this marker things. Okay, so that is another thing, another exercise for you, which is like now change the characteristic impedance of the transmission line to 50 ohms and the impedance of the load 80 plus J20 J times. I mean, well, so in that case, if you want to answer this question, you have to change and you have to go back straight right there. Okay, don't forget to save the pictures or save the simulation, save the results at any points. Oh, what I mean, because you might need those things anytime. So in that case, in this question, you are just changing here. Okay, the 80 plus J. Don't put cross, just 20, and see how it goes. I'm not going to run these things for you because this is for you to solve. I'm sorry, and provide the same plots that you have obtained the other previous steps, and explain how the plots have changed for this new loading condition. Remember, this is a complex loading. Okay, this is normally just a resistive loading. We have changed the loading as you are changing the impedance. So just have some comments how that I mean, how did you see that? Okay, so yes, I think we are done for today, and again, feel free to ask any questions whenever you come across, and just feel free to email. And I hope you have enjoyed this very small tutorial, and definitely that's going to be really beneficial for your next lab. Okay, you might be continuing from the same transmission line. You might need to look back to this again in the next session. So that's all for today. Thank you very much.